Hi everyone, welcome to our presentation. Today we're gonna talking about the predict greater senior house rental price in the Airbnb platform. My name is Yui Chen. Is my team member Bingzhi Hao. So first part is this is our content. So first part we're gonna talking about research background and evaluation setup and the model selection rules, result, and the model evaluation and conclusion and recommendation. So first part, I'm going to introduce the research background. So this project is predicts the greater senior house rental price from Airbnb platform. So it's aiming to predict the price based on the series input variable for the data Airbnb list from the cargo website. So firstly, we we predict the research assume the reliable model hypothesis test. So no hypothesis test for the research assume the reliable model is the occurring rate over the 0.5. However, the alternative hypothesis is assumed as the reliable model is the occurring rate is no over the 0.5. So evaluation setup, we add the regression project. The target variable for this problem is house price, and the independent variable contact with the numerical and the categorical data. So except for data clean procedure, we mentioned in the stage 1 dummy variable, we also grant for the categorical. So first variable year was extra for the original variable, and the last review and second variable distance and the location based on the house location. So price is, we can see this histograph, the price is the right scale, therefore transfer the variable price by taking log can help with the distribution and achieve a relative or normal distribution target variable. So therefore we're gonna use the R square AE to adjust square to analyze the result. So Christina, how gonna introduce the modeling?
So for the model training parts, we selected to use the linear regression, KN algorithm, and gradient boosting. Firstly, as a baseline for regression problem, a linear regression model was trained. In order to avoid multicollinearity issue, highly correlated variables were dropped from the predictors, such as the reviews per month, longitude, and latitude, etc. As the model results shown on the screen, the model can explain around 47.4% variance in the target variable to the total variance. But at the baseline for this problem, we may expect a better performance for other predictive models. For the KNN algorithm, new values will be appointed to the new point based on the level of similarities in the training dataset. So the number of neighbors is an important hyperparameter for KNN model training. Therefore refers to the graph shown on the left-hand side. The number of neighborhoods adopted for the KNN model is 14. As we can see from the results table, compared with the linear regression model, the KNN has a better performance and it can explain around 58.5% variance in the target variable to the total variance. Hence, it successfully improves the prediction performance. However, as the scatter plot shows here, this model might oversensitive to the scale of input variables and some irrelevant informations. The last model we trained is based on gradient boosting. So the gradient boosting algorithm aims to optimize the loss function through adding various weak learners to the additive model, and each weak learners will be trained refers to the previous weak learner's residue error. These procedures will be repeated with certain iterations until the model accuracy is satisfied. Similarly, this model will also require various hyperparameters in order to optimize its predictive performance. So we imported the random search cross-validation from the scikit-learn package. The number of iterations for parameter tuning was appointed as 32, and we also adopted the 5-fold cross-validation. Given the random search results, the learning rate was finally settled at 0.05, and the maximum depth is 6. Number of estimators is 500 and 0.6 for the subsample. According to the results table, the gradient boosting model has a larger R-square and adjusted R-square and a lower RMSE. So it can cover around 69.6% variance in the target variable to the total variance. Therefore, gradient boosting is the most reliable predictive model among all training models. Additionally, we can see from the variable importance bar graph, the private room is the most significant feature for house price forecasting, followed by other room types and several house locations. Therefore, we can say that both room type and house locations plays an important role for the Airbnb house rental price. Now, Kiki will introduce the model evaluation based on the test data set.
So model evaluation, we can see this table. So gradient boosted model has the best performance both the training dataset and test dataset. It covers the 56.7% variance in the target variable price to in the total variance. Comparing the gradient boosted and the MAE is 0.393 with the other two models performance. There is the feature based on training dataset is reasonable to conclude and is the gradient booster has at least the overfitting issue. So this gradient booster is less interpretive in the natural and take a longer time to model training. So conclusion and recommendation. So we can see the our recommend to adopt the gradient booster model is use the best train the hyperparameter to predict the senior Airbnb lease price, house price. And the recommendation we give the more hypothesis includes the other factors, and then include collecting the more data and the house price feature to get the full picture size, improve the predict the accuracy. Thank you, time. This is our the reference. Thank you.
PPT 还没改呢。